Here we are, continuing with the skeletal system. So you have seen the skull, the vertebral column, and the bony thorax, or the ribs and the sternum and the costal cartilage. All of that is the axial skeleton, and it's, at the center of us. The skull is a big and complex set of bones that does take time to learn, so I urge you to keep going on that. And now we'll get into the upper limb. The pectoral girdle is the set of bones that connect the upper limb to the axial skeleton. So that's what we'll see as we get into this. And your goal here will be, ultimately, you've got to be able to see any bone and know what it is. That's just all there is to that. You have to be able to see any bone from a human body and know what it is. For most of them, you'll have to be able to tell whether it's a left or a right. And for the bone markings, you have to be able to identify all the bone markings in the lab manual on that text-based list. So it is a lot to do. There's no way around that. It is a big task, so get to it. One thing I'll tell you is that people in the past, students who have used anatomy software, have done really well. And so starting with anatomy software gives you a quick route to learn things and quickly quiz yourself. So use it that way. But assume that this is a big task that will take a lot of time, because it just does. Memorizing things like this takes time, and being sure you've memorized it and not just put it in your short-term memory, that's tricky. Okay, enough of that. Here is what remains for us to see in the lecture slides. This is the upper limb. It has, well, basically this is what we call your arm bone, and the forearm, and the hand, arm, forearm, hand, and then the bones that connect it more or less to the trunk or axial skeleton. And then the next set of slides that we'll do the next day would be the pelvic girdle with the thigh, leg, and foot. So we are going to cover all of this today. So we start with the pectoral girdle. We always tend to start proximally and move distally. So why don't you tell me what proximal and distal mean when we're talking about an upper limb? 3, 2, 1, pause. Yes, so a way we could use those words would be the fingers are distal to the elbow, or something like that. So the most proximal part of the upper limb would be where it attaches to the pectoral girdle. And so the pectoral girdle is going to be the clavicle and the scapula. And what they don't do is form a ring around the body. What they don't do is form tight joints with the vertebrae. The pectoral girdle isn't meant to be the most stable, powerful joint. That's your hip joint. Your hip joint is meant to be very stable and very strong. Your pectoral girdle is meant to be your most flexible joint. It's meant to let your upper limb do kind of an amazing range of different motions. And that's what you're going to see. So the pectoral girdle itself can move a lot. And then the upper limb can move relative to the pectoral girdle. So what you'll see in the muscle unit is that there are a lot of muscles in the pectoral girdle that move the arm. And you know what? Let's get into it. So we start with the clavicles. The clavicle bones have two ends, so they have a sternal end and what we call an acromial end. You may remember, since you've been studying body regions, there's an acromial region. That's your shoulder. The acromial end is the part that is close to your scapula and your shoulder. That's a clavicle, and it goes from here where it forms a joint with the manubrium of the sternum, all the way to here where it forms a joint with the acromion process of the scapula. The acromial end of the clavicle forms a joint with the acromion process of the scapula, or the acromion of the scapula. And if you look carefully there, what it does is it goes superior to this bone. This is the humerus, or the arm bone, and this is the glenoid fossa, or the glenoid cavity, and the humerus forms a joint here called the glenohumeral joint. And so the clavicle and the acromion are both superior to the glenohumeral joint. So that's what that is. Now, what's tricky here is this is a bone that if you pick one up randomly, it would be very difficult at first to tell the difference between a left and a right, because it just looks like an S shape. But what you'd find pretty quickly is that the acromial end is very different from the sternal end, first of all. So let's hide everybody else and just look at this. So that's kind of the view we've had in the slides, but if I rotate it back, what I hope you can see is that this is flattened and this flares out like a trumpet. So no matter how we rotate it, if you look over here, it's pretty wide because it flares out like a trumpet. Whereas if we rotate it, the acromial end can be big or it can almost disappear because it's flattened. Also, this right here is the coracoid tuberosity, or the conoid tubercle. And this is going to form a joint with the coracoid process of the scapula. And this is a bump that only exists in this one place. So if you rotate the clavicle, you'll see there's only that bump in that one place. So those are the things to look for. Know the acromial end, the sternal end, and the coracoid tuberosity. Now I apologize, I keep doing this, whoa, whoa, and that's because that's how you set the center of rotation. So if you don't do that, if I do this and I try to rotate it, it's just all over the place. So instead, I set the center of rotation and then I can control it. Okay, that's a pro tip right there. So the clavicle would be your first bone of the pectoral girdle, and your second bone, and really the other bone of the pectoral girdle, is the scapula. And the scapula has a very complex, weird shape. At first, it's hard to tell what you're looking at, but this is another bone that once you get to know it, you'll just instantly know it. What it has is this big wing shape that is flat, and then it has this area, the glenoid cavity, and then these two processes, the coracoid process and the acromion process. So if I were to put all the bones back, so now we can just look at the scapula, and as we rotate it, I hope you can see that it's very thin. Part of it is very thin and flat. Thin and flat. This is your shoulder blade, so to speak. So you could imagine this being like the blade of an axe or something like that. And you can, this and the clavicle you can find on yourself pretty easily. I'll show you how to do that. But for now, what I want you to focus on are the different parts you can find. So we start with the biggest part, the body of the scapula. Next, if you rotate it, what you find is the acromion, that's this. It's flat, just like the acromial end of the clavicle was flat. So flat, it's kind of squashed like a pancake. I don't know if you can see that, but it's it's big from one direction and then it disappears from the other directions because it's flat. Well, that is something you're going to be able to find. And if you trace this along, you find the spine of the clavicle. And this is an important landmark because you're going to have the supraspinous fossa and the infraspinous fossa, supra above, infra below. And you're going to have muscles that go there, the supraspinatus and infraspinatus muscles. And they're all just named on their relationship with the spine. And then this one, the coracoid process, is kind of like a finger. And coracoid, if I understand correctly, means beak. So it kind of looks like the beak of some kind of a bird, I guess. I don't see it. I see a finger, but it doesn't matter. Just know coracoid process. And those are the major landmarks. I mean, you will need to know the bone markings, but those are the landmarks. So if I put these back together, we have the clavicle and the scapula together, and the clavicle is going to connect to the sternum, and the scapula doesn't form a joint with any of this. Instead, the scapula is held in place by a lot of muscles. And the idea is that the scapula can move relative to, it can move relative to the ribs and the spine. You can bring your shoulder blades together. You can move them apart. And what that does is let you do things like shrug your shoulders or push your shoulders forward or bring them back, and that gives your upper limbs more range of motion. So that's what that is for. So these are things to study, and this is another way to think about it. And then that brings us to the upper limb. So the humerus is the bone that's going to articulate with the scapula, and the humerus then is going to articulate with the ulna and the radius. So these are the forearm, this is the arm. Note that. When I say arm, I'm not talking about the whole upper limb. I'm talking about this part. When I say forearm, I'm talking about this part. That is an important distinction. Later on in the course, we're going to learn movements, and you will need to know words like flexion of the forearm. And if you write flexion of the arm, that would be a different movement. So let's see. And then here, the wrist, which anatomically we won't, we'll kind of ignore that. The 8 bones of the carpals, and then the other bones of the hand. So we'll go through all of those in turn. Okay, so the job of the humerus is really to be a strong connection between the forearm and the scapula. What you're going to see is that it has a rounded part up here to make a ball and socket joint, the glenohumeral joint, and then it has a rounded axle-like structure at its distal end that the radius and ulna rotate about. So it allows flexion of the forearm, flexion and extension. And so these are the markings I was talking about. So the trochlea and capitulum down here allow rotation of the ulna and the radius out here. The head of the humerus acts as the socket in the ball and socket joint of the shoulder. So before I cover the elbow and the markings of the elbow, I think it just makes sense to finish the shoulder and then stop this video and then start a new video of the elbow where we'll cover both the distal parts of the humerus and the proximal parts of the radius and ulna, because there's a lot there. The elbow has a lot going on. It's elegant, but it takes some time. So let's put these bones together. What we've been talking... Oh my God. You son... Okay, so complete anatomy crashed again. This is something you have to get used to. This software has bugs and it crashes, and you just have to restart it and get going again. So there's a learning curve and there's patience involved with this software, but it's very useful software. Okay, so right. Here's what we've seen. We've seen the pectoral girdle and the proximal part of the humerus. What I wanted to show you is some of the connective tissues that make this joint. First, we have the fibrous capsule around the actual glenohumeral joint. What this has within it is some, what's the word I'm looking for? Lubrication and things like that, synovial fluid, and we will talk about that later. Here we have ligaments connecting the coracoid process with the acromion process, and to some extent that's going to protect this from rubbing against the bones. And if we keep going, here we start to get what the coracoid tuberosity of the clavicle is for. It is a location where the clavicle can form a lot of connections to the coracoid process of the scapula. So that's enough for the pectoral girdle and the proximal humerus. So the next video we will move distally down the upper limb, and we'll keep doing that until we reach the end.